begin tonight with Dick Wilson, who is a transportation consultant in this area called Mag Lev, or Magnetic Levitation Systems. He received his PhD from the University of Colorado and worked with Dr. Oppenheimer. So you come from a deep physics background. Now you're in the business world. Tell me about this train and how it works in the most simple terms.
A long time ago, people decided that magnets could be used to carry things. So a system was developed that has rails. They're rails reminiscent of a freight train. But the train picks itself up from underneath, so the rails are suspended in the air like that. Train wraps around, and there are magnets underneath that lift it up toward the rail, but they never quite touch. And so, with a separation that's about ½ an inch, the train flies on a magnetic field anywhere the rails go.
Okay, and now, so my viewers are saying, what are they talking about? And I'll tell you why we both believe your group, your company group, I guess it's Mag Lev Transit Group, and I believe there's a place for this form of rapid transit in San Francisco, city of, if not the Bay Area. But when you look around the world, it hasn't been the United States that's adopted this technology in any fashion. There's a test site somewhere in Georgia. But tell us about elsewhere in the world where it is being used.
Recently, within the last 5 years, high-speed systems have been put into operation in various places. The Germans originally developed this beginning in 1972. And in 1973, the Japanese took a license from the Germans, and the two went in their separate ways, really divided by the speed that they wanted to get. So the Germans went for high speed. So with the German machines, you can go faster than 200 miles an hour, and that machine is installed and runs every day in Shanghai, in China.
From the airport?
It goes from the Pudong airport to downtown Shanghai. The Japanese, at the same time, decided to go for low speed, and this really has particular application to San Francisco. They have now installed, in 2005, in Nagoya, Japan, a little more than 8 kilometers of line that is used. It was used originally for an expo that was held, and now it's used for everyday transportation. It's been very successful.
When you're talking about low speeds, what are you talking about?
30 to 60 miles an hour, something in that range. Mm-hmm. But you can go as high as 100, if you push it. And the medium speed range, which has yet to be developed, is 125 miles an hour. And those machines are right around the corner. Actually, prototypes of them have been built but not deployed.
Now, the rails can be underground?
They can be underground if necessary.
Above ground?
But usually they're above ground. They're either at grade or they're hung on bridges. And, they're fully elevated and grade separated from everything else.
Let me ask you this, because when I was talking to your associate about this originally, do these, the overhanging kind, do they become a eyesore? Do they, in other words, we were talking about the Geary Street corridor, which is going to be, they're coming up with different supposed solutions, like rapid transit buses or subways. That's two ways they think, right? This is an alternative which we're offering. If you were to have such a train system, would it be an eyesore, or have you seen them in other cities where they actually blend in and become aesthetically interesting?
Well, you see these sorts of things every day in freeway overpasses, but those are ugly, and people don't like them.
Yeah, so especially in San Francisco.
Especially in San Francisco.
You live here.
Yeah,
you live here in San Francisco.
Well, the Embarcadero Freeway is a good historical example.
Or the Central Freeway, which they worked to tear down.
Yeah.
Right.
The nice thing is, in the past few years, specifically from 2002 to 2004, we worked with T.Y. Lin International, who are the designers of the New Bay Bridge, to come up with new ways to suspend these rails in the air. And this method of doing it is not ugly. They don't block the light. You can look right through them, and they're very good for weather. They don't block snow or blowing dust, things of that sort.
Do you think it is viable for a city like San Francisco to use them for, let's say, the Geary Corridor? I mean, have you actually pro bono or in your own mind come up with a concept for how it would work?
We do have a concept for that. We've been looking at it for quite some time, talking with both one of the supervisors, with a member of the Planning Commission and other people of that sort, and we believe it's definitely feasible. The difficulty with bus rapid transit, I have 2 kids that go to school here in San Francisco.
Okay.
I get daily comments about Muni and about the freeways, and the end result of all that is there's probably a way to make it a lot better. The performance of Muni, this is not to be negative about Muni, but the buses average 8 miles an hour. That's a very, very slow trip through the city, and it takes a long time to go from the Sunset clear to across town.
Cost per mile, whether it's a rapid transit, I mean a bus rapid transit lane, which they're proposing, and the cost of, let's say, a Mag Lev system like yours. Can you compare them, apples and apples, in terms of per foot or per mile?
It's very hard to compare them apples for apples because the performance level is different. We can do the same thing that the buses currently do at 8 miles an hour. We can do that at 60 miles an hour.
So, in other words, but you'd have to stop.
Well, it depends.
To pick up passengers.
You can run a mixture with these kinds of speeds and with what's called close headway, which means, every few minutes another one comes along. You can actually alter what you do. You can skip stop. You can take some people very rapidly from one place to another. You can take others more slowly. And so it's difficult to compare without actually running a computer simulation to show you what you'll get.
How about stations? I mean, one of the, this city complains about eliminating Muni bus stops that are one block apart from each other.
Right.
I mean, that's a major issue. It's important as the Iraq War to many people.
It totally is, and I relate to that. It's probably as important as where the public restrooms are located, right?
But, I mean, if you can't get the public to skip a few bus stops and walk a little farther, won't these train stations have to be widely separated?
Well,
how does it work in other...
Once again, this needs to be looked at, and we can only do so much to start with. But
right. But in other cities, how far, in urban cities, environments, how far do they space their stations where the passengers get on?
Well, it's really driven by activity centers. So let me give you an example. We think that in San Francisco, San Francisco is a wonderful city, but it's very dependent on tourism anymore.
It is.
A lot of the big companies have left. The shipping industry has migrated east. Everything is, it's kind of in a period of transition.
Yeah.
And the city's, at the same time, the city is developing. South of Market, there are huge buildings going up everywhere. There's going to be congestion, more and more congestion. So, and there are intractable problems. They want to connect Caltrain to the Transbay Terminal.
By subway.
Right. Good luck.
How much is it, do you know offhand, the cost per mile of a subway to construct?
Well, what I have been told...
Is it $1 billion?
Is that the 1 mile central subway is $1.4 billion to go...
From, which one is that?
Goes from 4th and King to Chinatown.
So with a $1.5 billion estimate right now.
Right.
Now, I know it's difficult, but can you assign a cost per mile for your system?
For Mag Lev, for urban Mag Lev, the cost, we believe, will not exceed $100 million per mile. We think that's competitive.
Okay, let me get this straight. We just concluded that the subway, the central subway to Chinatown, will cost $1.5 billion. How many miles is that?
It's 1 mile.
Okay, I want to repeat that. $1.5 billion for 1 mile of subway.
It's 1.4, but that's...
All right, well, it's going to be 2.
I'll give you 100
when
million.
They get finished with it.
Right.
And you're saying you believe that this system, this overhead rails, faster and so on, would be $100 million
$100 million a mile, yeah.
Okay, which is why I wanted you on the program. You've talked to some supervisors. You've talked to... This message needs to get out if it is indeed true what you're saying and what I discovered in preparing for the program. Why is this country not adopting this technology for the obvious Los Angeles, Las Vegas run, the Baltimore to New York run, the Boston to New York run? Why isn't it automatically a no-brainer in terms of understanding that this may be the best technology to move people rapidly?
I have an answer, but the answer is from my experience, so you should take it for what it's worth. It may not be a correct answer, but I'll give you what I think. There's a failure of leadership, and I'm not assigning this to any specific person in a specific geographic area, but there's a failure of leadership in the entire society. And that failure of leadership results in the creation of large bureaucracies that have no way to put new technology into what they do. They run like they're on rails, to put it kindly, and the end result of that is there become projects, and I'm not negative about projects, but projects that take on a life of their own, and there is no way to change them or stop them. If this same thing happened in medicine, people would be up in arms. If a new technique is found or a new drug that helps people and saves your life, the medical profession incorporates that in what they do. But when it comes to technology, it takes leadership. In the computer technology field, that leadership is provided by big companies like Intel, Google, all the familiar names. In the transit business, there is no such entity.
I see. There's no major corporate. There have been corporations that have devoted a great deal of resources, but there's no leader.
I used to work for one. I used to work for Otis Elevator. But in the political realm, transportation has been left to the political mechanism. And if you don't have leadership, political leadership to do this, you get nowhere, and you get what we have. Highway departments build highways. Too many highways have been built. They can't afford to maintain what they have, let alone build the ones they'd like to build. And the end result, when it's all over, is there is a vacuum, and the bureaucracies roll on.
I see. Do you think also it's the fact that some key players develop the lobbyist skills so they control the agenda because of their control over the people who make decisions?
Absolutely correct. A friend of mine used to say, the system is run for the benefit of the people who run the system.
So when you lack leadership, or you don't lack a market that makes decisions on its own, then people can dominate it.
Absolutely
by
right.
dominating. Obviously, it's government money, a lot of it.
Almost totally.
So it's he who has the best lobbyists.
Right.
Well, I hope that this program, starts something here in San Francisco. You live here. Your family lives here. I think this will work.
I do too, or I wouldn't be here.
I wish you the best. I hope this helps.
Thank you.
We've been talking with Dick Wilson, and from Mag Lev Transit Group, and we hope you enjoyed tonight's program. And tell your friends about it if you agree with us that this is something that should be in San Francisco. We'll see you next time.